Mr. M presents Area of the Wonderful, the Magnificent, the Majestic Trapezoids. Hello everyone. In this video we're going to take a look at finding the area of trapezoids. We're going to try and come up with a formula that can help us do that in any situation. What we're looking at right now is, of course, not a trapezoid. It is a parallelogram. But we're going to use parallelograms to help us come up with our formula for area of a trapezoid. So let's do a quick reminder about finding the area of a parallelogram. So area of a parallelogram, area equals length times width. Just the same as any rectangular or other parallelogram. So in this case, the area of the parallelogram equals 6 centimeters times 4 centimeters, and that equals 24 square centimeters. Pretty straightforward, right? So the trick with finding area of a trapezoid is that, unlike a parallelogram, a trapezoid, A, doesn't have all parallel sides for starters, and B, when you look at the length and width, well, it does have a simple width, but the length of both bases, in this case 3 meters and 5 meters, are usually different from each other. In fact, they always are to make it a trapezoid. So that throws off our formula a little bit. So it really helps if we think about a trapezoid as part of a larger shape. So what I have here is I have a second trapezoid, exactly the same shape and size as the first one, but just inverted, turned over, and I'm going to add it, I'll leave just a little space so we can see here, to my first trapezoid, and I have created a new shape, and hopefully you recognize the shape that I've created. It is one large parallelogram. And knowing I've got a parallelogram here can help me because now I can complete a full base. So I know that if it's 3 meters at the top of my trapezoid here, then it's also 3 meters right here, because they are the same shape. And if it's 5 meters right here at the bottom of my trapezoid, then it's also 5 meters right here. So what this allows me to do is it allows me to add these two numbers together to get one complete base. So what I can do is I can find the area of my parallelogram, which, as we said, equals length times width, because now I do have a width and I do have a length across the base. So in this particular case, the area of my parallelogram equals 5 meters plus 3 meters, because that combines to give me the length of the base, times the width, which is 3 meters. For anybody who's having any difficulty following that, take a look. Here's my base, and that brings me here, and here is my width, that brings me here. So how does that work out? Well, it works out to area equals 8 meters times 3 meters. Area equals 24 square meters. Now there's one important thing that I still need to do. I just found the area of a parallelogram. But remember, what I wanted to do was to find an area of simply one trapezoid. So what do I need to do? Well, I need to get rid of this trapezoid right here. And since the two trapezoids are exactly the same, I need to take this number, 24 square meters, and divide it by 2. So my final area of my trapezoid is going to be 12 meters squared. So what have I come up with so far? Well, if I have a parallelogram, I can use that parallelogram to help me find the area of a trapezoid, because a trapezoid is 1/2 of my parallelogram. So in that case, I'm going to add my two bases, the top base and the bottom base, multiply by the width, and then divide it by 2. So let's see what that looks like without the added trapezoid and without the added crutch of using the parallelogram. Let's just use my trapezoid here. So in this case, I have a very clear width, 6 meters, and I've got a very clear couple of bases, one that's 8 meters and one that's 5 meters. So what I have to visualize in my mind, and I'll draw it in here very crudely, is that there is a second trapezoid here, and that second trapezoid is going to be the inverted version of my trapezoid, which means that this side would be 8 meters and this side would be 5 meters. So what am I going to do without having that extra trapezoid? Well, I'm going to say that the area of my trapezoid equals 8 meters plus the other base, 5 meters, times 6 meters. And then because it's only half of that original parallelogram, I have to remember to divide it by 2. So what have I used here? Well, if you take a look, this is the real helpful part. If I only have the one trapezoid, look, I have both my bases, the 8 meters there and the 5 meters there, because the inverted one is just the opposite of what I had, the 5 meters here and the 8 meters up here. So I've got all of it, all of what I need here. So in this case, my area would equal 13 meters times 6 meters divided by 2, and that would equal 78 meters squared divided by 2, and that would equal 39 meters square. So now we definitely have a formula. The area of my trapezoid, area right here, is going to be base 1, let's say this base right here, plus base 2, let's say this base down here, times the height, which is this measurement right here, straight up and down, and of course divided by 2. So there's my formula. The two bases added together give me the one full base of the imaginary parallelogram, and they're both in my trapezoid, so I don't actually have to draw in or even picture that parallelogram as long as I pay attention to both the bases and I add them together. Then I multiply by the height, which is always going to be the width between my two bases, and I always have to remember to divide by 2, because basically what I'm finding is the area of a parallelogram, and then I need to cut it in half, because half a parallelogram works out to be a trapezoid. Okay, so let's try with this somewhat unusually shaped trapezoid here, a little bit different than what we've looked at, which is good. And I'll let you give it a shot, pause the video, and then come back and we'll solve it together. Okay, let's see how we did. Now, this trapezoid has already identified the top base, the bottom base, and the width or height, whatever you want to say, which is 7 meters. So, let's think about my steps. I want to imagine that imaginary parallelogram, which means I need both my bases together to give me one long base. So, my area formula equals B1 plus B2 times H divided by 2. Because, of course, all of this part up to this point would be as if I had a parallelogram. Since I only have half a parallelogram, I need to then divide by 2. So let's punch in our numbers. So in this case, the area equals 4 meters plus 11 meters times 7 meters divided by 2. So area equals 15 meters times 7 meters divided by 2. I'll bring it up here to continue. So area equals 105 meters squared divided by 2, and that means that my area is going to equal 52.5 meters squared. Okay. Okay, so let's just take a quick look at what we did here. I first found the complete measurement for both bases so that I could get this full base down here. Then I used the height to multiply, and what was really important at the end here is I remembered that I had to divide by 2 because a trapezoid is only half of that parallelogram shape. Okay, so there we are. That is how we find the area of a trapezoid without the extra help of a parallelogram.